sine graph is going to go this 1 2 3 4 5 6. So the nature of sine curve is going to be like this. One, two, three, four, five, six. Okay, this is sine theta. Cos is going to be exactly same nature. Only change is that there is a lag of pi by 2. This is going to be your sine cos. Then tan at pi by 2 is undefined, minus pi by 2 undefined. अरे stop share ला click झाला. Pi by 2 undefined, and it will pass through 0. At 45 it is going to be 1, so it is going to go like this. Mistake. Okay. Now this nature of the curve, when it goes near pi by 2 or near minus pi by 2, is called asymptotic. Okay, asymptotic, and then again you will have another branch like this. 1 2 3 dotted here at 3 pi by 2. This is how it is going to be, tan theta. Okay, natures are important to be remembered, as well as you need to be able to sketch them very quickly whenever you want. And we said that we can construct these lanes using our unit circle. Sine was direct, where this term sine was blue. So sine is where it intersects your terminal ray. This distance was sine. Corresponding, this distance was ray. Sine is ray. Sine is red. So if this is your terminal ray, then this is your sine value. Then blue is cos. This is your cos value. This is sine value. And if you happen to draw tangent at 1, 0, wherever that terminal ray intersects, this is going to be your tan value. That is how geometrically we have understood the different values, and our x-axis decoration, x-axis naming is exactly same. We need to know what is the nature of cosec, sec, and cos. Of course, we have defined them differently. Now, let me complete this semicircle make it very bad. Then we have my axis of this unit circle here. Suppose we want distance which is equal to cosec theta. This is theta. Suppose we want distance is equal to cosec theta. Then the idea is draw tangent at P. Then this is 90 degree here and this is also 90 degree here. So this distance from here to here is going to be cosec theta. Cosec theta. Understood? Check why. Because this distance from here to here is sine theta. Therefore, that distance is cosec theta by complete Pythagoras theorem. And this distance is cos theta. This distance is sec theta. Complete Pythagoras theorem. Cos theta into sec theta is equal to 1 square. That is what is our Pythagoras. Is it correct? Yeah. You have to consider this triangle. Maybe let me name ABC, C center. In triangle ABC, this foot of perpendicular is sine theta, this distance, and where it intersects, it's cosec theta. So sine theta into cosec theta is equal to CB square. That is how you are supposed to get geometrically those distances and plot. If you do that, then your cosec theta will look like this. Sorry, this is sec theta I am drawing. And it will go like this. Should I make little difference between sec theta and sine theta? But sine theta you have already drawn, so whatever is the other thing which I am drawing is sec theta. From here it is sec theta. This, okay, and so on between these two dotted lines, because these dotted lines are also not acceptable as far as sec theta is concerned. Okay, because they will, denominator will become 0. As far as cosec theta is concerned, the n pi angles are not acceptable. Therefore, this is y axis is not acceptable. At pi it is not acceptable. At minus pi it is not acceptable. So these are the dotted lines. These are the asymptotes for sine, and sine curve will be similar to cos, but one will be at pi by 2. This is sine theta. This is cosec theta. And inverted cups will be here for cosec. Another cup will be here for cosec. There will be cup like this for cosec, and so on. Something like this. Okay, this is cosec. And as far as tan theta is concerned, okay, how do we get geometrically the tan theta value? You draw tangent at 0, 1. And wherever your terminal ray intersects, let me draw that circle here differently. Suppose you have a circle here, unit circle. Draw tangent at 0, 1, and your terminal ray is intersecting unit circle and this ratio. Okay, then this distance is cot theta. Why? Because this angle is theta. because this angle is theta. Okay, this is 1, and if this angle was theta, then this x and this is y. So x upon y, sorry, y, yes, sine is y. So cot is cos upon sine. So x upon y is your cot, and here this is x and this is y. Therefore cot theta upon 1. Therefore this distance is cot theta. So I have told you where geometrically will be sec theta available, where geometrically cosec theta available, and where geometrically cot theta will be available. I have shown you, and now therefore the graph of cot will look like, for cot 0, pi, they are not acceptable. So it is going to be decreasing. At 45, both of them will intersect, and it will pass through this point, and it will again pass through at I mean, this is a rough sketch, something like this. This is your cot theta, first cycle. Second cycle will be like this side. Okay, now that is why you are required to draw 6 graphs on 3 graph papers, because if we draw them one above the other, it is difficult to understand we have drawn. But I have used different colors, and therefore it might be useful to you. You might have understood it. These graphs are extremely important, and you should be able to reproduce them in few seconds, because you have spent good amount of time in drawing them in the first place. So you should be able to reproduce them in few seconds in your notebook whenever required. Moreover, when we will learn inverse trigonometric functions in 11th standard, after 5 months of training or 4 months of training, at that time we will assume that you remember these graphs, and then we will start discussing about how do we define inverse trigonometric functions, etc. Therefore, it is important that you learn them, and these graphs are going to be very useful. If you are in trouble, you do not remember what is the value of any trigonometric ratio of any theta, specific theta, you can always go back to these graphs and figure out what should be the value. Okay, so now let us continue with our discussion. Now the situation is, we said theta belongs to R. That is what is the difference that we have made in our 10th standard trigonometry or IIT trigonometry. Theta belongs to R. So if theta belongs to R, eventually, no matter what is the rotational history of your terminal ray is going to come and rest somewhere after that theta value is attained. It will not be continuously rotating. So the idea is, doesn't if theta is belonging to R, but then some other value, let us say theta dash, who is related to this theta, is going to be between 0 to 2 pi. I said this is principal value. Correct? So the whatever is the terminal ray diagram for theta belonging to R, its corresponding ray diagram. So that those two diagrams are going to be congruent. They will look alike. They are not going to be different. Only value of theta is going to be, say, 5000 degrees. Corresponding theta dash will be between 0 to 360 degrees. But the terminal ray is going to look like terminal ray. Terminal ray will look like terminal ray. And therefore, let us think we have done that exercise. Can you catch, say, theta is equal to 1000? degree. Can you tell me corresponding theta dash? This is good exercise. Tell me corresponding theta dash. Okay, if theta is 1000 degree, then theta dash is 280 degree. Next question is theta is 27 radians. What is theta dash? You should remind me. Theta is 27 radian, pi is 3.14 radian, 2 pi is 6.18 radian. So 4 times 2 pi is 20.5.12 radian, which is less than 27, and 10 times pi is 31.4, which is greater than 27. So 27 is caught into consecutive 2 pi, 4 2 pi and 5 2 pi. Therefore, actual value of the terminal ray, angle terminal ray, is minus 25.12, which is 1.18, and terminal ray here is going to, this is going to be 27 radian, or you can call this terminal ray as 1.88 also. Okay, so for all practical purposes, all the 6 trigonometric ratios, so sine 27 radian is exactly equal to sine 1.88 radian. Cos 27 radians is equal to cos 1.88 radian. Tan 1000 degree is exactly same as tan of, how much you said, 280 degree, and so on. Because the geometry of terminal ray is exactly same, all 6 trigonometric ratios of whatever theta belonging to R that you have, there will exist one theta dash between 0 to pi by 2 pi, which will have all 6 trigonometric ratios exactly same. That is the discussion we are trying to do. So for every theta, there will be theta dash between 0 to 2 pi, who will give you all the trigonometry ratio properties exactly same. That simplifies our job, because if we study 0 to 2 pi well, it is as good as we study theta belonging to R well. All trigonometric properties, if studied well between any angle between 0 to 2 pi, 0 to 360, exactly same study will be required for studying all the angles between theta belonging to R, whether it is positive, negative, or 0, real number theta belonging to R. Is this understood? Okay, up to this point it is true. If you find out for any corresponding angle theta belonging to R, if you find out value of theta dash between 0 to 2 pi, all 6 trigonometric ratios for theta and all 6 trigonometric ratios for theta dash, they will behave well. Very good. But how are you sure about, suppose theta 1 comma theta 2 belongs to R? We will be able to get corresponding 0 less than equal to theta 1 dash less than 2 pi, and 0 less than equal to theta 1 theta 2 dash less than 2 pi. And if I say consider sine of theta 1 theta 2, can I say confidently that sine of theta 1 plus theta 2 is confidently yes, sine of theta 1 dash plus theta 2 dash? Can I say confidently, unless and until really I am sure about it? So can you be little sure about this? I think this is correct. Sine of theta 1 plus theta 2 is going to be equal to sine of theta 1 dash plus theta 2 dash. Why? Prove.
Sir, but what?
Okay. Let theta 1 belong to 2 pi n plus theta 1 dash where n belongs to z. Theta 2 belongs to 2 pi m plus theta 2 dash m z. Now consider theta 1 plus theta 2. 2 pi n plus 2 pi m dash plus theta 2 dash, which is 2 pi inside bracket n plus m theta 1 dash plus theta 2 dash, which is equal to 2 pi times k, where k is, I should write here, k belongs to z. Okay, so we will be able to catch between two consecutive k's plus 1. We will be able to catch this theta 1 dash plus theta 2 dash, and therefore 1 dash plus theta 2 dash is bound to be between 0 to 2 pi, no matter where this theta 1 and theta 2 are. Always going to be possible, and therefore say sine of theta 1 plus theta 2 is bound to be equal to sine of theta 1 dash plus theta 2 dash, because geometric diagram of theta 1 dash plus theta 2 dash is going to be exactly same as geometric diagram of theta 1 plus theta 2. Therefore, all trigonometric ratios cos theta 1 minus theta 2 is going to be equal to cos theta 1 dash minus theta 2 dash. Always going to be true. That means what we were saying is correct, that corresponding angles, principal values of those angles, if you study well, it is okay. It is as good as you studied the theta belonging to R very well. Okay, consider a unit circle, and I am considering three rays, one CA, CB and CE. CB is making alpha angle with positive x-axis. Now alpha belongs to R, alpha comma beta belonging to R. So terminal history, whatever rotation history is there, it is available. Beta is the angle which CA makes with positive x-axis, and then alpha minus beta, that means this angle, is copied here, and we get point E. Out of A, B, C, D, E, coordinates of C is 0, 0, coordinates of D is 1, 0. What will be coordinate of A? That is my question. What will be coordinates of A? Cos beta, comma sin beta. Coordinates of B are cos alpha, comma sin alpha. Coordinates of E are cos alpha minus beta, comma sin alpha minus beta. Oh, good. And therefore, triangle ABC is congruent to triangle ECD by SAS test. Therefore, AB equals EDC चुकलं ना ECD EDC पाहिजे. AB equals ED. Oh, good. Therefore, AB square equals ED square. Therefore, distance formula, therefore, simplification, generate an identity. Okay, AB square, x1 minus x2 bracket square, that is cos beta minus cos alpha bracket square plus sin beta minus sin alpha bracket square is equal to cos alpha minus beta minus 1 bracket square plus sine alpha minus beta square, which is cos square beta minus 2 cos beta cos alpha plus cos square alpha plus sine square beta plus sine square alpha minus 2 sine alpha cos sine alpha sine beta is equal to cos square alpha minus beta minus 2 cos alpha minus beta plus 1 plus sine square alpha minus beta. Oh, good. We have cos square beta, we have cos sine square beta. That is 1. We have cos square alpha, we have sine square alpha. That is 1. And we have cos square alpha minus beta. अरे चेंज का नहीं होता कलर. Cos square alpha minus beta and sine square alpha minus beta. That makes it 1. So in LHS I have 2 and in RHS I have 2, and hence I get an identity cos of alpha minus beta is equal to cos alpha cos beta plus sin alpha sin beta. That is the first breakthrough. Summation of or difference of two angles and its cos ratio is cos into cos plus sine into sine. Okay. This formula is important because in LHS there is one identity, in RHS it is something like sigma 2 which is available with us. Sigma 2. Summation of two products. And this is where trigonometry is going to be very, very useful. I mean, not today's lecture, but next lecture we will prove that some identity plus some identity is equal to some identity into some identity. This kind of transformations will be required for algebraic simplifications later on. And who will help us at that time? Trigonometry. Tan A plus tan B plus tan C is equal to tan A, tan B, tan C. We will prove this for triangle ABC. This is good. LHS is sum, RHS is product, and they are equal. So whenever we require a situation that, oh, my algebra would have been good if all these three terms are in summation form, unfortunately I am getting them in product form. You can think of substitution trigonometric. That is why these formulae are going to be useful. And moreover, algebra of trigonometric ratios are also going to be very easy. If we go back to basic angles, these are basic angles related to the angle which is given to us. And if angle is known, cos of that angle is known. If angle beta is known, cos of angle beta is known. And therefore, even if you do not know cos of alpha minus beta, you can always find it out. Like cos of 15, you can find it out. Because I can see cos of 15 as cos of 45 minus cos of minus 30, which is going to be equal to cos of 45 cos of 30 plus sine of 45 sine of 30, right? And therefore cos of 45 we know 1 upon root 2, cos of 30 we know root 3 by 2, correct? Sine of 45 we know root 2, sine of 30 we know half. Therefore this is what is the angle cos 15. This is bad, but this is correct. Big courtesy, this formula, breakthrough formula that we have found out. So this again goes back to unit circle. This again goes back to SAS, congruency, the basic things that we did in 8th standard. And this again goes back to AB square is equal to AD square, distance formula in two-dimensional geometry. And this again goes back to Pythagoras theorem. Because distance formula is Pythagoras theorem. So that is why this entire chain is important. That is why understanding everything right from the scratch is important. It is fashionable these days that 9th standard, 10th standard students start talking about sine alpha, cos alpha, tan alpha. They see some videos, they mug up some formulae like this, and they start discussing that I have derived this, I have derived that. But unless and until you have developed the entire theory very systematically, it does not take much time. We will finish trigonometry very fast, very fast. But if we have done it systematically, we don't leave any loophole, any weak link. You can always go back, and you can start from wherever you are strong and come back to the formula that you are required to remember. If you forget. Do you understand? Similarly, now only one formula we have to write. We have yet to write 3 more formulae. But suppose cos 75, if I ask you, oh, that is good. Oh, nice. Good. Can I use alpha minus beta and get 75?
Yes, sir.
90. Yes, 90 minus 15. 90 minus 15 and cos, I know. What is the better method?
120 minus
120 minus 45.
Cos of 120 minus 45. 120 is friendly angle, 45 is friendly angle. We will be able to get cos 75. But then before we do all these things, let us see. Now, if I know cos of alpha minus beta is equal to cos of alpha cos of beta plus sine of alpha sine of beta, can I find out cos of alpha plus beta? Okay, to find out this, before that, let me do this exercise. Sine of theta. Sine of theta is what? You draw terminal ray, look at y coordinate. This is sine theta, which is LHS. And this is angle theta. What is minus theta? What is minus theta angle now? Exactly same, but clockwise direction. This is minus theta. So this is going to be your terminal ray of minus theta. If you look at sine of minus theta, you will reach here. This is sine of minus theta. Okay. So what is the relationship between sine of theta and sine of minus theta? Negative. You understand? Or we can say sine of opposite of theta is equal to opposite of sine theta. That is again visible and easy to understand if you go through the graphs. If you go through the graphs, which hopefully I have upstairs, yes. What is sine? Sine is this red curve. Suppose I take this value of theta, I look at this point, this is my sine value, y coordinate. What is opposite? This is theta, this is theta. What is opposite of theta? Exactly same distance on the other side. This is opposite of theta. I have to look here. The heights are going to be same, except this is going to be negative coordinate and this is going to be positive coordinate. Therefore, sine of opposite of theta is equal to opposite of sine theta. And do you understand what I am trying to say? Geometrically, we need to get these answers, and therefore few more questions for you. Cos of opposite of theta is equal to tan of opposite of theta is equal to, then cosec of opposite of theta is equal to sec of opposite of theta is equal to cot of opposite of theta. There, I will give you 1 minute to complete this. Cos opposite of theta is cos theta. Tan opposite of theta is opposite of tan theta. Cosec is same as sine, therefore opposite of cosec theta. Sec opposite of theta is sec theta minus cot. Now do this. Cos of alpha plus beta. As alpha comma beta belonging to R, for the first formula, we can always put beta is equal to, we can always write this as cos of alpha minus beta, which is equal to cos
Yes, sir.
alpha cos of opposite of alpha plus sine of alpha sine of opposite of beta. Okay. Next step is cos of alpha. Cos of opposite of beta is cos beta. We have just now proved. Sine of alpha, sine of opposite of beta is minus sine beta. So this is the formula for cos alpha plus beta. Find, okay, and hence find out cos of pi by 2 minus beta equal to. In right angle triangle trigonometry also, we were aware that cos pi by 2 minus beta should be sine beta, and using this developed formula, we could find out exactly same. Here beta is not between 0 to 90. Here beta is real number. That is the difference between this formula and the formula we learned before 10th standard. I mean before we begin this. Okay, next. Now we have done something about sine. Now, can we do something about, okay, we have done something about cos. Can we do something about sine now? Can I do something about sine? Sine of alpha minus beta. Find out. We have proved cos of pi by 2 minus beta is equal to sine beta, correct? I had missed this deliberately. Find out sine of pi by 2 minus beta. Even if we have not developed formula for sine yet, we can do this. Sine of pi by 2 minus beta is equal to, how do we go about this? We know sine beta is equal to cos pi by 2 minus beta. Therefore, sine, instead of beta, we put pi by 2 minus beta. So, sine beta is equal to cos of pi by 2 minus pi by 2 minus beta, which is equal to cos of beta. Correct? And hence, we should find out sine alpha minus beta. Sine alpha minus beta. Is equal to cos pi by 2 minus alpha minus beta. Now, one mistake that you will do is you will apply cos formula for this, and then you will get 0 is equal to 0. I think somebody has got 0 is equal to 0 because of that. Or sine alpha minus beta is equal to sine alpha minus beta. You will get that once you apply cos pi by 2 cos alpha minus beta plus sine pi by 2 sine alpha minus beta, you will end up getting sine alpha minus beta, but that is not the idea. Therefore, we should not apply formula directly to this just like that. we should slightly modify. Pi by 2 minus alpha plus beta. This is good. This is cos of pi by 2 minus alpha. Cos plus cos of summation of two angles is cos minus sin. Right? And hence cos of pi by 2 minus alpha is sin alpha cos beta minus sin beta cos alpha. This is sin alpha minus beta, and hence we got the third formula. Sine of alpha plus beta, which is simple. Sine of alpha cos of opposite of beta minus sine of opposite of beta cos of alpha. Because we substitute beta is equal to opposite of beta, then we get into the earlier formulae. Therefore sine alpha cos beta plus cos alpha sin beta. Okay, so these are fundamental four formulae of trigonometry. Using this, any good angle, friendliness. So therefore, earlier we had only 0, 30, 45, 60, 90 and so on. Only multiples of these with people were friendly angles. Now differences of those two, addition of these two, those are going to be few more friendly angles. Okay, because we know sine cos of those angles. Okay, therefore now we can generate, if we have these four formulae with us, we can generate plenty of formulae in no time. 1, sine 2a is equal to, second, cos 2a is equal to, in three forms, in terms of cos and sine, in terms of only cos, in terms of only sine. Cos 2a has got three formulae. सांगा बघूया चारही गोष्टी या. Sin 2a 2 sin a cos a. Cos 2a is cos square a minus sin square a. 2 cos square a minus 1. 1 minus 2 sin square. Third, tan 2a. In terms of tan. Oh, you can find out tan 2a in terms of tan a. Okay, in terms of tan a to start with. Before that, we have to find out tan a plus b. Na? Tan a plus b. Find this first and then find tan 2a. Correct? Sin a plus b is equal to sin a cos b plus cos a sin b. Good. Divided by cos a plus b is cos a cos b minus sin a sin b. and we want to get into tan. Therefore, dividing everything by cos A cos B, we get tan A plus tan B upon 1 minus tan A tan B by dividing numerator by cos A cos B cos A cos B. This term in the numerator divided by cos A cos B, this term in the denominator divided by cos A cos B. Now, are we allowed to do cos A cos B? Because allowed to divide, yes. I mean, A and B are supposed to be good angles, and therefore cos A and cos B are well defined, and therefore we should be able to divide them. If we can write, if cos A is equal to cos B is not equal to 0. Cos A comma cos B is not equal to 0. We are allowed to divide, and we will get this formula. If they are 0, then you go back and deal with this little differently. Is it okay? So this is tan A plus tan B upon 1 minus tan A tan B. Similarly, you can find out tan of A minus B, and it will come tan A minus tan B upon 1 plus tan A tan B. And therefore, if you put A and B same A both places, you will get 2 tan A upon 1 minus tan square. These are the first formulae, basic. Now, see, now geometry of the angles, geometry of sine, cos, tan, their definitions, that is far behind now. We have used geometry to define them. We have used geometry to find out our first compound angle cos formula, and from then we are just doing algebra of trigonometric ratios. And because the angle is real number, we really need not have to go back and check what is happening to geometry. Is geometry in place? Geometry is definitely in place, and it is coming along with this algebra of trigonometry. And we are getting so many different important formulae ready for problem solving in future. Okay, that is what is this lecture. Next lecture we will derive 20-25 new formulae for this. So, but in the beginning of next lecture, you need to remember whatever we have derived. I can ask anybody to tell me what is sine alpha minus beta, what is cos 2a, etc. And instantaneously you should be able to tell me that without looking into the notebook.